Hello everyone. Welcome to the course Database Management System. In this lecture, we will discuss about database system applications, then purpose of database system, view of data, finally database languages. Let us see one by one. Coming to database system applications examples, if we can consider any enterprise information. So what enterprise information contains? Sales, accounting, human resources. Sales, customers, products, purchases. Whereas accounting, payments, receipts, assets. Then human resources, information about employees, their salaries, and their payroll taxes. So these are all various things included in any enterprise. So this is the information related enterprise. If we can consider manufacturing, what type of information it contains? Management of production, inventory, orders, and supply chain. These are all various factors involved in manufacturing. And then coming to banking and finance sector. Here customers with their information, accounts, loan details, and banking transactions. Then if it is credit card related transactions. Then if we can consider finance, sales, purchases of financial instruments, for example, stocks and bonds, storing real-time market data. These are all banking and finance related. If we can consider universities, registration details, and student grades. These are all various database applications examples. Then if you can see the next application, airlines. So airlines, what it contains? Reservations and schedules of flights. If you can see telecommunication application, records of phone calls, texts, and data usage, and generating monthly bills, maintaining balances on prepaid calling cards. If you can see the web-based service application, online retailers, what it contains? Order tracking, customized recommendations, then online advertisements. If we can consider document databases, then navigation systems. Navigation systems, what contains? For maintaining the locations of various places of interest, along with the exact routes of roads, train systems, buses, etc. These are all navigation related information. These are all some of the database applications example areas. Okay, by seeing all these applications, now we can understand the importance of database system. So that is purpose of database system. In the early days, database applications were built directly on top of file system. That leads to data redundancy and inconsistency, difficulty in accessing data, data isolation. In our previous lecture, we discussed about comparison of file system and database system. So the disadvantages of file system can be overcome in database system. Here these are all again reviewed. Data redundancy and inconsistency. Here data is stored in multiple file formats, which results in duplication of information in different files. Difficulty in accessing data. Here need to write a new program to carry out each new task. This is the difficult one. Then data isolation due to multiple files and formats. This data isolation problem occurred. Then integrity problems. In integrity problems, integrity constraints. For example, you are having account balance greater than 0. It become buried in program code rather than being stated explicitly to handle this situation. It is hard to add new constraints or change existing ones. So in file system, this is the problem occur. Then atomicity of updates. Here failures may leave database in an inconsistent state with partial updates carried out. For example, transfer of funds from one account to another should either complete or not happen at all. The transaction completed or not yet completed. So this type of examples leads to atomicity of updates. Then another issue, concurrent access by multiple users. Concurrent access needed for performance. Here, uncontrolled concurrent access can lead to inconsistencies. For example, two people reading a balance, say for example 100, and updating it by withdrawing money, for example 50 each at the same time. So parallel task actually. So this leads to concurrent access by not only single user, multiple user. Then security problems. So it is very hard to provide user access to some, but not all data. These are some of the drawbacks of file system. These can be overcome in database system. Finally, database system offers solutions to all these problems. So that's why this is the advantage of database system comparing to file system. So let us see one example database, university database. So university, what it contains, everyone knows. It contains departments, students, faculty, then various classes. So here data consists of information about students, instructors, classes. So application program examples, what type of operations you can perform on university database. So if you want to add new students, instructors and courses. If you want to register students for courses and generate class rosters. And also you want to assign grades to students and compute grade point averages, that is GPA, and generate transcripts. These are all some of the operations are possible to perform on university database. Then coming to how to view data. View of data is one of the important concept in database. View of data. A database system which is a collection of interrelated data and a set of programs that allow user to access and modify this data. So that is the role of database system. A major purpose of a database system is to provide users with an abstract view of data. Abstraction means data hiding. Only basic details are shown, implementation details are hidden for security purpose. So here first data models plays important role, then data abstraction. Data model, what is a data model actually? A collection of conceptual tools for describing data, for data relationships, data semantics and consistency constraints. So that is the data model. Then data abstraction hides the complexity of data structures to represent data in the database from users through several levels of data abstraction. There are various levels of abstraction that we will see in later lectures. Okay, then coming to data models. So data models plays important role in database design. So how to define a data model briefly? A data model which is a collection of tools. So what it performs, it describes what is the data, then the relationships among the data, then data semantics means validations, then data constraints, rules, conditions. So a data model is a collection of tools for describing data, data relationships, data semantics, and data constraints. Okay, there are various categories or types of data models. The first one is very important one, relational model. The second one is entity relationship model. This we will call it as ER model. This is familiar name. ER stands for entity relationship data model. This is mainly used for database design. Then we are having object-based data models, which are combination of object-oriented and object-relational. Then we have semi-structured data model. The example is XML, Extensible Markup Language. So we are having other older models, network model, hierarchical model. In upcoming lectures, we will discuss in detail about all these data models. Okay, here briefly let us see first relational model. So in relational data model, this was introduced by E.F. Codd in 1970. Currently, it is the most widely used data model. So here the diagram shows the picture of the founder E.F. Codd, so who was won by Turing Award in 1981. So all the data is stored in various tables. Tables also called as relations. So in previous lecture, we already discussed about introduction to database and database management system and the role of relations or tables. Okay, let us see example of a tabular data that can be represented in the relational model. This is the table. So here you can see, here we are having attribute 1 ID, attribute 2 name, department name, another attribute salary. These we will call it as columns or attributes, also called as fields. These are the various names. Then we are having rows. So here you can see this is row 1, row 2, row 3 and so on, row n. So these we will call it as actually rows, also called as records, also called as tuples. In relational database management system, these are all the terminologies or notations we have to remember. So this is the example of tabular data that can be represented in the relational model. This is single table. The name of the table is instructor table. If you can see multiple tables, so there is another table, department table. So department table contains name of the department, then department building name, then department budget. So another table, instructor table already seen. It contains ID, name, department name, salary. These two tables are related. Here you can see department name is repeated. So in later we will see integrity constraints at that time, how to combine multiple tables using various integrity constraints that will be demonstrated. Here just we are seeing the examples of relational database. Okay, that's all briefly about relational model. Later we will discuss in detail in upcoming lectures. So then coming to, so earlier we have seen data abstraction. So there we mentioned various levels of data abstraction. So what are the various levels? Here you can see levels of abstraction. We are having physical level, logical level, view level. Majorly 3 levels are there. 3 levels of data abstraction. So physical level, which describes how a record is stored. For example, instructor in the previous example, how a record is stored physically. Logical level describes data stored in database and the relationships among data. The relationship among the data. For example, we are having instructor. It can be defined as type. It is record type. Then we are having ID. So identifier. So it is of string. Then name. It is of type string. Then department name. It is of type string. Then salary. It is of type integer. Then end. So this is the declaration of records of the instructor, the relation instructor. The relation instructor type is record. What are the attributes? Attributes are columns. or fields in relation we already seen. So ID is one attribute, name is another attribute, department name is another attribute, salary is another attribute. So the relationship among data is defined in logical level. Then coming to view level, your application programs hide details of data types. Views can also hide information. For example, an employee's salary, maybe that can't be disclosed publicly. So some important information can be hidden. The reason for security purposes. So in view level, data can be hidden. Then whichever the data that can be viewed based on the privileges. So this is the diagrammatic representation of view of data with various levels what we mentioned. So the bottom level we will call it as physical level, then the intermediate level is called as logical level, then the top level is called as view level. So view level contains many views like view 1, view 2 and so on, view n. So this entire one we will call it as architecture for a database system with respect to view of data. So that is abstraction levels. Then what is instance and what is schema? So here instances and schemas. Similar to types and variables in any programming language, instances and schemas. So here we are having like based on level, we are having logical schema, we are having physical schema. So logical schema, what it describes the overall logical structure of the database. For example, the database consists of information about a set of customers and accounts in a bank and the relationships between them. Similar to type information of a variable in programming language. So the logical schema is similar to that. Then physical schema, what it gives the overall physical structure of the database, the storing of the data. So here two schemas, logical schemas and physical schema. Then coming to instance, the actual contents of the database at a particular point in time. This is similar to the value of a variable in any programming language. That is the instance. So the schema and instance are very important terms in database systems. So then we are having data independence. So first we are having physical data independence. So here the ability to modify the physical schema without changing the logical schema. So that is physical data independence. Here applications depend on the logical schema. So in general, the interfaces between various levels and components should be well defined so that changes in some parts do not seriously influence others. So that is the physical data independence. So then coming to database languages. So we are having various database languages. Sometimes we will call it as DSL, database languages. So here, majorly we are having data definition language, which is denoted by DDL. So the data definition language specification notation for defining the database schema. So here, for example, create table is the example of data definition language. So if you want to create a table, create a relation, so the create command is part of data definition language. What is the syntax for creating a table? Create table, table name. Then within function as parameters or arguments, you can define the attributes and their data types followed by size. So here instructor is the name of relation or table. Then ID, name, department name, salary. These are all attributes of the table instructor. So for every attribute, for example, ID, the type is data type is character. For example, here the length is 5. The name is the next attribute. It's varchar. Varchar is nothing but its size is varied. Suppose here 20 characters maximum length is given, but your size is only 10. That remaining 10 that can be reused, that is varying. So varying character, its size is 20. The department name also varchar 20. Then salary, which is a numerical value. So here with the floating point combinations, we are given 8, 2 decimal points. So here to run the DDL commands, we'll use compiler, which is called as DDL compiler. DDL compiler generates set of table templates which can be stored in a data dictionary. What is a data dictionary? So data about data. So that we will call it as metadata that can be stored in data dictionary. So later we will discuss all data definition language commands in detail with SQL practical demonstration. So this is just introduction about data definition language and one example command, that is create command. So here data dictionary, just now we mentioned what it contains: metadata, that is data about data. What it contains: database schema, integrity constraints, then primary key. Here identifier uniquely identifies instructors, for example in the previous example. Then authorization, who can access and what data they can access. So data dictionary consisting of these. Then another database language, data manipulation language, which is called as DML. So data manipulation language mainly for accessing and updating the data organized by the appropriate data model. So this data manipulation language also known as query language. You want to retrieve data, you want to access data, you want to view data, we'll use data manipulation language commands. There are basically two types of data manipulation languages. One is procedural data manipulation language, another one declarative data manipulation language. In procedural data manipulation language, which requires a user to specify what data are needed and how to get those data. What data and how to get those data. Whereas declarative data manipulation language require a user to specify what data are needed without specifying how to get those data. Declarative, here specification is not given, simply it concentrates on what data needed. Whereas procedural, it concentrates on what data is required and how to get that data. Both will be concentrated. So here declarative data manipulation languages are usually easier to learn and use than or procedural data manipulation languages. Declarative data manipulation languages are also referred to as non-procedural data manipulation languages. The portion of data manipulation language that involves information retrieval, which is also called a query language. So later we will discuss various commands related to data manipulation language similar to data definition language. So then coming to another important one, structured query language, also called as SQL. So it is, read it as SQL or SQL, stands for structured query language. So SQL query language, which is a non-procedural. Here a query takes as input with several tables, possibly one, and always returns a single table as the output. For example, to find all instructors in computer science department, the query you can write using select statement. Select. So here name of the instructors from, this is the instructor is the table name, table or relation name. Then condition you can use under where class, where department name equal to computer science. So here table is instructor. Here selecting attribute name you want to select. So this is the output you will get. So name whose department is computer science. So for computer science A, B, E, F. For example, here department is computer science. So all computer science related instructor details are displayed. But in the select class, we have taken only name. So only name only displayed, but department won't display. Suppose you want department also. Suppose here you can use DEPT. Select name comma department from instructor where department name equal to computer science. Then this will also display. This is the output. So using select class, you can select whichever the attributes you want to view based on the condition. Condition you can define it where class. So this is one of the way of writing query. So this can be done in SQL, structured query language. So SQL is not a Turing machine equivalent language. So what is actually Turing machine? Turing machine is the most powerful computational language comparing to all other formal languages. Its computational power is very high comparing to other languages. To recognize the languages, Turing machine is used. Turing machine is the abstract mathematical model of computation, which is a powerful computation model. So to be able to compute complex functions, SQL is usually embedded in some high-level programming languages. Like earlier semester, you studied object-oriented programming using Python in last unit database. How the database used in Python programming languages we already demonstrated. That is, so embedded SQL commands in some high-level programming languages. Some application programs generally access databases through one of language extensions by allowing embedded SQL. Then some application program interface which allow SQL queries to be sent to a database. For example, here ODBC, JDBC. ODBC is Open Database Connectivity. If you want to embed into some other programming languages, whereas JDBC stands for Java Database Connectivity. Suppose if you are using database in Java programming language, this connection interface will be used, JDBC. These are actually drivers to connect database to front end. Front end means the languages. So then database access from application program. How to provide database access from application program? So here, by using non-procedural query languages like SQL, so which are not as powerful as universal Turing machine. We already mentioned the Turing machine. Universal Turing machine is encoded as a binary. That means digital format, the binary, where the computer understands zeros and ones, machine language. So here SQL does not support actions such as input from users, output to displays, or communication over the network. So this won't be supported by SQL. Such computations and actions must be written in a host language, for example, either C language, C++ language, Java language, or Python, with embedded SQL queries that access the data in database. For example, by using SQLite CRUD operations implemented in Python language. By writing Python program, you can implement CRUD operations. Here CRUD operations are create, retrieve, update, deletion operations. These are the major operations in SQL. So application programs are programs that are used to interact with database in this fashion by writing in host languages like it may be a C programming language, C++ language, Java language, Python language with embedded SQL queries. Okay, here the contents taken from database system concepts by Silversketch and Core, the 7th edition. These are all the links available. So you want to see the complete slides related to database system concepts from the textbook, Silversketch and Core. Here you can use this link. Complete slides are there. Some solutions to practice exercises are available here. You are having online SQL interpreter also that was developed by the authors of that book. Some sample lab exercise and term projects also available here. You can make use of all these resources if you want to get expertise in database management systems. In upcoming lectures, we will come up with other new interesting topics.